Good day to all of you. Today we shall see to attribute closure and candidate key part 1. In previous video I have discussed attribute closure with many examples. Today's session is extended version of that. By the end of this video you will come to know how to use attribute closure to find candidate key in a table. Let's start the session. In today's session we shall take student table as an example, and for this table using attribute closure we'll find first super keys. From that candidate keys are derived, and we shall extend the discussion to find primary key. First, in student table we'll have to find the super keys. Super key is a group of single or multiple attributes that can uniquely identify rows in a table. So student ID is the key attribute here. It can be used to uniquely identify row in a table. Hence student ID is a super key. Then according to these lines, if closure of an attribute set or single attribute contains all attributes of the relation, then that attribute set or single attribute will be super key of the relation. So with student ID we can determine the value of itself. Then we can determine the value of name attribute, phone attribute, state, country and age attribute. Hence closure of student ID attribute is this, that is student ID plus, that is closure of student ID attribute, since it can determine the values of all the attributes including itself, that is the set of all the attributes in the relation. So according to these lines, if closure of an attribute contains all the attributes of the relation, then that attribute or set of attributes is called as super key. So functional dependency set, if you take student ID closure shows that it is a super key, then any other attribute combination with student ID also forms a super key. So student ID name is a super key. It also has all the attributes in the closure. The next will be student ID name phone. The next one student ID name phone and state. So this way we can derive many super keys for student table. So this I have covered in my previous video, keys in DBMS. Please you watch, then it becomes very easy to understand this topic. With this what we can say is out of functional dependency set. So these are all functional dependency sets. So from functional dependency set, if you take student ID comma name, this super key, it is a super key because it can identify any row uniquely in the table, or the value of student ID and name. So the values of these two attributes can determine the values of other attributes also. Hence student ID comma name is a super key, but it is not a candidate key, because the proper subset of this, which is student ID, it is also a super key. Hence student ID name is not a candidate key. So if you take a super key, if its proper subset is also a super key, then that super key is not a candidate key. So according to this definition, if this is the super key, its proper subset is also a super key. Hence this super key is not a candidate key. Next, this proper subset, that is student ID, which is a super key, it is the minimal super key. Hence student ID is the candidate key. So what is the procedure here? We'll have to write super keys using attribute closure. Then in that super key, if it is having any proper subset which is also a super key, then this super key is not a candidate key. Then we'll have to check for its proper subset. If it is also a super key and if it is minimal, and that becomes candidate key. This is how using attribute closure one candidate key is found in this student table. Next we'll have to verify are there any other candidate keys. So if you observe in this table, phone is also a key attribute. With the value of this, any row can be identified uniquely. Hence phone is also a super key. Then FD set, if you consider, The attribute closure of phone attribute is the set of all attributes in the relation, and hence phone attribute is the super key. Then with phone, the combination of any other attribute also forms the super key because its closure will have all the attributes in the relation. This way with key attribute phone, the combination of other attributes also form super keys. Many super keys we can write here. So from functional dependency set, if you consider phone comma name, the set of these two attributes, this is a super key. This is not a candidate key because it's a proper subset. Phone is also a super key. Hence phone comma name, it is not a candidate key. Phone is a super key because it can determine all the attributes of relation and its closure contains all the attributes in the relation. It is a minimal super key. It has minimum number of attributes when compared to phone comma name. Because it is minimal super key, phone is also a candidate key. This is how using attribute closure we have found first super keys. From that minimal super key becomes candidate key. One candidate key is student ID. Then another candidate key is phone attribute. So this table has two candidate keys. One is student ID, another is phone attribute. Now out of these two, primary key will be chosen. So we have come to know that from super keys, candidate keys are derived. Next, from candidate keys, primary key is chosen. Minimal super key is candidate key. And next, how to choose primary key from candidate key. First, we shall compare both. Both primary key and candidate keys can have one attribute or set of attributes. Both can uniquely identify rows in a table. Both are minimal super keys. But what is the difference between the two is a table can have only one primary key, but table can have more than one candidate keys. That is first point. Primary key can never be null, whereas candidate key can be null. Both have unique values. So one concluding statement is primary key cannot have duplicate values and can never be null also, whereas candidate key cannot have duplicate values, okay, like primary key, but it can be null also. So that is the difference between primary key and candidate key. Both cannot have duplicate values, whereas primary key is stricter than candidate key. That is, primary key can never be null, whereas candidate key can be null. So for the student table taken, there are two candidate keys, student ID and phone. Out of these two candidate keys, student ID is chosen as primary key. Choosing primary key is done by database administrator who looks after the database. Here phone attribute also has the potential to become primary key, but out of these two, student ID is chosen as primary key because every student has ID. Students will be given university seat number. So every student has got ID. But every student may not have phone number. But the definition of primary key is it cannot have duplicate values. That is first point. Of course, phone number will be different. Student ID also will be different for every student. So they have unique values. But primary key can never be null also. In that respect, every student has student ID. So we can fill some value in the table for student ID. Whereas if student doesn't have phone number, we'll have to fill null value for the table. In that respect, student ID is chosen as primary key. That completes the discussion on attribute closure and candidate key part 1, in which student table is taken as an example. In next session we shall take some more examples how using attribute closure we can find candidate keys and other aspects involved. Stay tuned. I hope you have understood. Thank you.